All right, on this worksheet, you want to find the intervals where a function is increasing, decreasing, or constant, and then state no where there's no intervals. Also indicate the relative maximum or minimum for each. Okay, so we're talking about increasing, decreasing, or constant. The intervals that go here, or the numbers that go in these intervals, is going to be your domain. So remember your domain, you use domain here. So the domain remembers a set of x values. So as you go along the x-axis, so you have to go along the x-axis. So as you go along the x-axis, you're looking at what happens. Remember, f of x is the same thing as y. So you're looking at what happens when the y, what happens to the y values as you go from left to right. Okay, so if you look at your domain, if you kind of color the x-axis, as I go from negative infinity to, let's say, 2. So I'm looking at 2 for right now, and you'll see why. But as I go from negative infinity to 2, look at your y values. So as I'm going this way, as I'm going to the right, look at what happens to your y values. My y values are getting larger and larger and larger. So they're increasing. And then it reaches a plateau. And then all of a sudden it is decreasing. Your y values are decreasing, 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 and then you have a bottom part and it starts increasing. So in this case, as you go from negative infinity to negative 2, negative infinity to negative 2, your y values are increasing. So they're increasing from negative infinity to negative 2. Now, we always use open intervals. We use open intervals when discussing increasing, decreasing, constant. So we're just using open intervals. Don't use closed intervals. Use open intervals. So when talking about finding the domain and range, that's where the intervals closed brackets or parentheses would become important. Okay, so then from negative 2 to positive 2, see, from negative 2 to positive 2, look at what happens. So in that interval of those x values of that domain, from negative 2 and 2, as you go from left to right in that interval, look at what happens to your y values. My y values are decreasing. So they're getting smaller and smaller and smaller. So you see, you can even see it. The largest y value here is 16. Then all of a sudden, right here it's 12. Right here is 8. Right here it's 4, 0, negative 4, negative 8, and so on. So they're decreasing. Your y values are decreasing. So in this part, it is decreasing. So it's decreasing from, remember, open intervals, negative 2 to positive 2. And then from 2 to infinity, from 2 to infinity, look at what happens to your y values. So your y values, so at 2, here's my lowest point, and then notice what happens to those y values. So your y values, see right here, the y value is negative 12, the y value right here is negative 8, the y value right here at this point is negative 4, the y value at this point 0, 4, and so on. So it's increasing. So in the interval from 2 to infinity, it is increasing. So it's increasing in two intervals, from negative infinity to 2, union, and then 2 to infinity. So notice that nowhere was a constant. So you just say nowhere. All right, now let's talk about relative max, relative min. So a maximum point, a relative maximum point would be the highest in a local area. I wouldn't don't I'm not saying it's the highest point you see. It's just that in one little piece of that domain. So if you look at this part right here, see as you go from increasing to decreasing, that's a high point. It's not the highest. There is no highest point because it just keeps on going up. But but there is a high point, a local high point. So relative kind of means the same thing as local. And so in that little local area, so if you look at this little part of the domain here, this little part here, right here, and you look at this, so on either side, so if you look at this y value is higher than, let's say, this y value. And so notice you're going from increasing to decreasing. So this point right here, that point right here would be considered a relative or a local maximum point. And the same thing right here. This right here, see how you're going from, you're decreasing, all of a sudden you're increasing? That would be considered a local, this point right here would be considered a local minimum point or a relative minimum point. Okay, so relative to that part of the domain, that little piece right here, then that's the lowest point in that little area right here. That's the lowest point. And so to answer these part of the questions, you may want to label those points. So that point is 2, -16. And this point right here is -2, +16. All right, now these are considered points that I just noted. Now let's answer the question. At what value or values of x is your function, your y value, a relative maximum? So this is the only relative local maximum point I have. So this maximum point occurs when x is -2, and the relative minimum, the relative maximum, so when they ask for the relative maximum, they're talking about the y value. So the relative maximum is 16. All right, over here, at what values of x is your function or your y value a relative minimum? So this minimum point occurs when x is 2. And the relative minimum, meaning the y value, that's what we mean here. So remember, the relative maximum is the y value. So the relative minimum is -16. All right, number 2. So number 2, you kind of do the same thing for increasing, decreasing, constant. So I'm going to use, so remember, you're looking at what part of your domain goes here. So as you go from -infinity to -2, right here. So as you go from -infinity to -2, look at what happens to those y values. And remember, you always go from left to right. When you read a graph, you go from left to right. So as you go from left to right, from -infinity to -2, your y values are increasing. So these y values are getting larger and larger and larger. And then it reaches a high point, and then all of a sudden it's decreasing. So this is increasing, then your y values are decreasing, and they're decreasing from -2 to -1. That's where they're decreasing, just right here. So in that part of the domain, from -2 to -1, your y values are decreasing. See, this y value, this x coordinate right here is -2, and this x coordinate where it reaches its low point is -1. So this is decreasing. Then from -1 to +2 right here, from -1 to +2, look at what happens to those y values. Your y value stays constant. This y value is -1, this y value is -1, this y value is -1, and so on. So that's constant. And then from 2 to infinity, from 2 to 4, excuse me, from 2 to 4, look at what happens to those y values. So from 2 to 4, your y values are increasing. They're increasing. And then, so that's increasing here. And then from 4 to infinity, from 4 to infinity, your y values are decreasing. Okay, so they're decreasing right here. All right, so I'm going from increasing, decreasing, constant, increasing, decreasing. All right, so we're going to put those intervals here. So I'm increasing from negative infinity to negative 2. And I'm also increasing from 2 to 3. I am decreasing, my function is decreasing from negative 2 to 1. So remember, that's your domain that goes here, your x coordinates. So the intervals. So negative 2 to 1. And remember, we always use open intervals to discuss increasing, decreasing, constant. And it's also decreasing from 4 to infinity. And then it is constant from negative 1 to positive 2. All right, so that is, notice I have, make sure you count the intervals, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, now let's talk about relative max, relative min. So remember, relative means local, so in that little local part of that domain, where's your maximum point, where's your minimum point? That's the question. Some of it is pretty obvious. For example, this point right here, where it goes from increasing to decreasing, so in that little area right here of the domain, that is a relative or local maximum point. So that relative maximum point is negative 2. You can't see it very well, but that's a positive 2. Negative 2, positive 2. Now let's skip this for a moment and let's go here. So here, so you're going from increasing to decreasing. So when it goes from increasing to decreasing, it's pretty obvious that that's going to be a relative maximum point. So when it goes from increasing to decreasing, that will be a relative maximum or local maximum point. When it goes from decreasing to increasing, that will be a relative or a local maximum minimum point. Excuse me. So right here, you have a relative maximum point. So there are two relative or local maximum points. And so that occurs when x is 4 and y is 3. Now it turns out in this particular case, and we didn't discuss that in this particular section, it's not located in this section, but there is such a thing as an absolute maximum point and an absolute minimum point. So notice that if you look at the graph, see how these outer parts are decreasing? So this happens to be the highest point on the graph. You can actually locate the highest point on the graph. So that would be an absolute. This is also considered an absolute maximum point. All right, just to let you know, but if, in this section of your textbook, it didn't discuss anything about absolute. Everything was relative. Okay, so now let's talk about what happens here. So remember, in that part of the domain, so if you look at this part of the domain where that point is right here, I am decreasing and all of a sudden I'm constant. So notice that this y value next to this, so these y values next to that point in comparison to these y values next to that point are higher than these. So that would be considered a relative min. All right, now all of these are minimum values. So look, the smallest y value on this graph, in terms of this little area right here, excuse me, in terms of this part of the domain, is negative 1. So when we talk about relative min here, this is a special case. Usually most of the time it's going to be very obvious, so look, things like that. But here where it's constant, so in that part of the domain here, in that part of the domain, this would be considered a relative min. So there's a relative min. So all these are relative minimum points. All these, because they're the same level, let's say, horizontal level. So all these are relative minimum points. So when we talk about relative min here, when we talk about relative min, we're going to use an interval to denote the x values. So all these going from -1 to +2, from -1 to +2, that would be where x is a relative min. So x is a relative minimum from -1 to +2. Now, what is that relative minimum? Well, the relative minimum, the smallest y value you see in that little area right here, in that localized area, is -1. All right, so that one, that part here where you have a constant, that's a little confusing. So it's different than the others. See how this one right here is more obvious. So at what values are the relative maximum? So it's pretty obvious you can see that because you can see where it goes from increasing to decreasing, from increasing to decreasing. Over here though, you're going from decreasing to constant and then from constant to increasing. All right, so all these would be considered relative minimum points. So that will be written as an interval. So over here, where's a relative maximum? So the relative maximum occurs at two x values, at x equal -2, comma, and the other one is at x equal 4. And the question is, what is the relative maximum? So we're talking about the y values here. Well, they are, so this y value is a +2, and this y value is a +3. All right. Okay, so that takes care of the key to worksheet 2.2, part 1.